Good evening, everyone. I hope I am clearly audible. So, if you can give me a thumbs up or a yes, we can quickly get going with our session on time and work. So, we're waiting for your responses. Let me know. We've already had few sessions. One on average mixtures allegations, another one on right solving with regards to some sets from mathematical reasoning or quant-based reasoning. So, I hope things working perfectly fine. Yes. All right. So let's get going. Now, the first part that I'll take up is actually bring all of us on the same page with regards to the terms, parameters, and the typical method that we are going to use while solving questions from time and work. So there are basic four terms or parameters that we need to understand very, very clearly. Once we are on the same page with regards to that, I think question solving from the previous year's papers, be it 25, 24, 23, in that reverse order will take up. But that should be pretty easy and straightforward to understand once we know what are the terms or parameters we are talking of. So let's start with this particular set of four terms. So when we talk of these four terms, remember the first term that we'll refer to is men, typically symbolized by the capital letter M. Then we'll have rate, then time, and the product of all these. So work will be proportional to the product of these three parameters. Typically, this is something that we call as MRTW structure: men, rate, time, and work. So these are the parameters that we are going to refer to. Now let's quickly understand what do we mean when we refer to these parameters and how are we going to use them when we solve actual questions from previous year's papers. So men typically can refer to people with symbols A, B, C, etc. They could also refer to group of people. For example, if there are 10 people working, we can write the number numerically as 10 in the column for A. Or we could have a combination of these. For example, there are a category of people and there are 5 members in team A. So we can refer to them as broad category A and the numerical value being 5. So this is pretty straightforward. Then rate is also sometimes called as efficiency. Typically will define as per unit of anything. So whatever be the efficiencies with which people are working, will refer to them as rate. Let's say two people are working in such a manner that A is twice as efficient as B. So we can say that the corresponding rate for A will be 2 and the corresponding rate for B will be 1. A is twice as efficient. Then comes the part on time, which is the amount of time that people take to complete the piece of work. So it could be days, hours, minutes, depending on the unit that is given. So let's say somebody is working for 5 hours. So we'll simply write the numerical value 5 in this particular part for T. And the product of these parameters will write as corresponding value for work. This exact product is not equal to work, but work is proportional, directly proportional to the product of these three factors. We can assume either a value which are multiples of time and so on and so forth, which we'll be able to figure out once we look at questions. But the basic idea should be clear. I'll take a very simple example to demonstrate essentially what we are going to do with the structure of MRTW. So let's say if there is a person A who can complete a piece of work in 20 days, there is another person B who can finish off the work in 30 days. Now, if somebody asks us in what time will both of them together complete the piece of work, so I'll write A plus B in terms of in front of M. This will give me the structure to calculate the amount of time required when both A and B are working together. So the way to solve this would be, we will take the LCM of these two numbers. We could take any number for that matter. We could write 1 here, we could write the product of these numbers 600, but a more convenient way is to take the least common multiple so that calculations are easier. So the LCM of 30 and 20 is 60. I'll take 60 as the work. This is my assumption. I could have assumed anything else. But if 60 units is the work and it takes 20 days for A, then if we divide 60 by 20, we'll get the number as 3. This is nothing but the rate. So this person A completes 3 units per day if the work is assumed to be 60 units. So for 60 units, this person completes 3 units per day. And B similarly completes 2 units per day. 60 divided by 30 would be 2. So in all, if both of them are working together in a day, they'll be able to complete 5 units of work, and 60 is the total work. So we'll divide 60 by 5 and say they'll together take 12 days. This is very similar to what a lot of us typically do. 1 by 20 is the per day's work, 1 by 30 is per day's work for B. We add the per day's work for both of them, and we say what is the per day work required to be completed for total work, and then we simplify this and get the answer. So this approach is nothing but a different representation of the very same fundamentals of proportionality, nothing else. So having understood this, and this was just so that all of us from anywhere, any part of the country that you're watching, all of us are on the same page with regards to what is this structure MRTW. So M refers to men, R refers to rate or efficiency, T for time, and the product of all these three is proportional to work. Now it's time for us to move towards the set of questions from actual CAT papers. Now just a bit of background with regards to the actual CAT papers. As I said in the proportional short as well, that a lot of times time and work is considered to be one of the easiest topics to have in in any competitive exam for that matter, not just CAT, because the questions are pretty straightforward, the concepts are limited, you study it for 2-3 days at best, and you're good to go to solve questions which are CAT level. But having said this, if you look at the last 3 years papers, specifically the last 3 years paper, CAT 25, CAT 24, CAT 23, you will realize that a lot of questions from this very topic were very time consuming, or they were genuinely difficult. And we are going to look at all those questions along with some easier questions as well, which is why this topic was considered easy in the first place. So we'll have a good mix of all the questions, because we are going to go sequentially in reverse order from CAT 25. We'll have a good mix, but it will give you a good taste of what the questions are, what could be the approach, and even if they are time consuming, is there a way to navigate and somehow get to the answer faster, or is it better advised to leave such questions from the get-go? Let's start with this question from CAT 25 slot 3. So just observe this and develop the skill of deciding whether this is a question of type A, type B, or type C. Type A typically would mean you would attempt this question right now. Abhi karo. You will want to do it right now, straight away. Type B would typically mean that you will want to mark it for review and come back later. And type C would mean you will probably not solve it unless you've solved all the A type and B types. So, all right. Now, in this much time, I would say if you just quickly go through this data, that the rate of water flow. So we are already given rates for 3 pipes ABC. Pretty familiar data. An empty tank can be filled up by pipe in 15 hours, which means if we multiply this ratio with 15, 4 with 15, we can assume the work to be, because rate and time are given. Multiply them, will corresponding get the total work that is required to be done, which is nothing but the capacity. So pretty much straightforward data. If all 3 pipes are used, then the time to fill up. I think a very easy, straightforward question. We can have this basic structure and just fill in the values. So I'll say there are 3 pipes ABC. The rates are corresponding in the ratio of 4, 9, 13. Correct? Pipe A takes 15 hours. So if we multiply 15 with 4, we can say 60 hours. 60 hours taken by A is the corresponding work. So 60 is our basic unit for work. Now this very 60 work is expected to be done by all 3 pipes simultaneously. So basically we just want A, B, C to be working together. So if we add the rates 4 and 9, 13 and sorry, my mistake, this is 36. So 4 and 9 and this is 36. So 13 and 36, this rate comes out to be 49. If this rate comes out to be 49, the time required is pretty simple, 60 by 49. Unfortunately, there is no option with 60 by 49. Why? Because the question is saying the time in minutes required to fill up the entire tank. Whatever we have calculated is in hours. How do we know this? This was 15 hours. So this answer is correct, 60 by 49 hours. So if we simplify it and calculate the decimal part, 49 ones are 49, remainder will be 1110, 49 to the 98, 12, 49 to the 98, approximately 1.22 hours. You want to convert it to minutes, just multiplied by 60. At this stage, you could use a calculator if you feel you're very nervous, anxious about dividing these numbers. But I think this should be pretty straightforward. So 12 6 are 72 and 73.2. So approximately 73.2, maybe even slightly higher than this because we have not calculated the third place of decimal. So slightly greater than 73.2. Question is saying nearest to. Correct answer option 1. Yes, I got that correction, Priya. Thanks for reminding. 4 is to 9 is to 36 is the corresponding rate. I got that corrected. Thanks to your message. All right. So, any confusion, any questions on this? If not, let's move ahead to the next question. All right. Now again, pause for a few seconds. Try and see whether you will rate this question as type A, type B, type C, and then we'll get going with our approach to solving this. All right, let's move ahead. So teams A, B, and C consist of 5, 8, and 10 members respectively. Again, as usual, just like DLR, respectively is an important keyword whenever you come across this. So we already have data for how many members each team has, and every member within a team is equally productive. What do you mean by this particular word? That every member within a team is equally productive, which means the efficiency or the rate for each of these individuals across one team. It may be different for different teams, but for one team, any team member, choose any two members across any one particular team, their rates would be same. Working separately, teams A and B and C can complete a certain job in 40 hours, 50 hours, and 4 hours respectively. So we are given number of people in teams and the amount of time that they take in hours. With this, we can calculate the rate typically associated with each person. And now they are saying 2 members from team A, 3 from team B, and so on. So just on the basis of language, on the first glance, it may look time consuming and therefore you might want to mark it as B, but definitely not type C. Depending on your comfort level with this topic, you can mark this as type A or type B. Definitely not type C. Why? Because there is nothing difficult that you will not be able to solve or understand or comprehend. You might want to still attempt later on if time permits. And if you are good at time and work, you've understood that this particular data represents a straightforward case of number of people and working hours, you might still want to do it straight away. Uh, am I not audible properly? I think everything is fine. Yes, I'll discuss how to tackle approaches as well parallelly. So we'll create this particular structure of MRTW, straightforward structure for men, rate, time and work. And now uh, let's write down the corresponding people. So we have teams ABC. So these are the 3 teams we have, and we have 5 members here, 8 members in team B and 10 members in team C, such that every member in a team is equally productive. So let's assume their rates for each member in the team to be ABC, small a, small b, small c. And now they take 40 hours, they take 50 hours and 4 hours respectively. If they do so, what will we do? We'll multiply all these 3 MRT to get the corresponding value for work. If we do so, we get 40 into 5, 200A, 50 into 8, 400B, and 40 into C, 40C. All these represent the same work that these people are doing independently as team A, team B, team C. So if all of them are equal, it is a good idea to assume all of them to be equal to a certain value that can give us the ratio of ABC. So this is something that you have studied in ratio proportion variation. Take LCM of 200, 440 and divide by these values, you'll get the corresponding ratios for ABC. or equate them to the value of LCM. So 200, 440, LCM will be 400. So I am now assuming the work to be 400 units. If 200A corresponds to 400, I can get the corresponding value for A to be 2. Similarly, 400B is actually 400. I'll get the value for B as 1. And if 40C is 400, I'll get the corresponding value for C as 10. What are these ABC? These are the rates of one person. For example, any member from team A will complete 2 units of work in 1 hour. 2 units of work in 1 hour. Whereas any member from team C will complete 10 units of work in 1 hour. So that if the work is 400, they'll be able to complete with the given data of 40 hours, 50 hours and 4 hours. I hope this is fine. Now, what else are they saying? So they're saying 2 members from team A, 3 members from team B, and 1 member from team C start the job. So now, what is it that they are starting with? They are starting with 2 members from team A. So I can say 2 people multiplied with their individual rates 2A, 3 members from team B, so we'll have 3B, and 1 member from team C, so we have C available here. Remember, the values of A, B, C are available with us, 2, 1 and 10, with the corresponding total work being 400. Now what they're saying, they start the job and the member from team C leaves after 23 hours. A standard line that after a certain period of time, a certain member leaves. The moment this person leaves, they've still worked for 23 hours. So you can calculate how much work would they have done in 23 hours. After this person leaves. So we are still left with 2A plus 3B as the group. 3 person has left, will still be left with 2A plus 3B as the people from team A and B. Now, what is the amount of work that these people will do? So I'll put in or plug in the values for ABC. 2 into 2, 4. A value of A is 4. Plus 3, 7. Plus C is 10. So we have 17 into 23. How do you calculate 17 into 23 quickly? The average is 20. So 20 minus 3, 20 plus 3. That is A minus B into A plus B. So, just to calculate 17 into 23 quickly, it's a good idea to assume this to be 20 minus 3, 20 plus 3, A plus B, A minus B, A square minus B square, which is 400 minus 9. 400 minus 9 would be 391. So understand that so far, by the time C left, 391 units of work was already done. What is left is 9 units of work. Just 9 units of work is left. We already have the group 2A plus 3B. Now they are saying the number of additional members from team B that would be required to replace the member from team C to finish the job in the next 1 hour. So we want this job to be finished in the next 1 hour. What will these people do in the next 1 hour? Let's try and find that out. So 2 into 2, 4 plus 3 into 1, 7 units will already be completed by these people in the next 1 hour. What is required to complete 9? We need additional 2 units of work. And they are asking how many additional members from team B. A person from team B contributes 1 unit of work in 1 hour. We require 2 units of work, so we'll require 2 more people. So correct answer for this question will be choice 1, 2. See, with the given people, we were already able to produce 7 units of work in 1 hour. We required 9 more hours because 391 was already done. 391 plus 9 would have fetched us the total work of 400. To complete 9, we just required 2 more units. And 1 person from team B is able to contribute 1 units of work. So understand that if you present the data in this manner, in a structured manner of men, rate, time and work, it becomes very easy for you to follow along without any confusion. We've been able to solve 2 questions from CAT 25 slot 3. There were 2 questions only from CAT 25 slot 3 from time and work. Let's move ahead. So now a question from slot 2. Look at this question, try and rate it as type A, type B, type C, and then try and figure out the best possible way to do this. All right, let's look at this particular question. Ankita is twice as efficient as Bipin and B is twice as efficient as C. The moment you look at this, only 2-3 sentences, definitely type A, you should jump onto questions of this type, get them right as quickly as possible and move on. I'll create the structure MRTW. I'll create spaces for these three people ABC, and I'll just quickly understand the ratios. A is twice that of B, whereas B is twice that of C. So I'll assume the rate of C to be 1. B is twice, so it will become 2. A is twice of B, so it will become 4. Straightforward. All three of them start together on the job. So A, B, C, all three of them start 4 and 2, 6 and 1. They'll start with a rate of 7. Perfect. And B leaves the job after 20 days. Again, look at the statement. It is very similar to what we encountered in the previous question. Somebody leaves after certain days. Whatever happens after certain days is in future, at least they'll be working together for 20 days. So we know that for 20 days ABC worked together, and now B would leave. So we would be left with A and C. And what are the rates of A and C? 4 and 1, 5. So they'll be working with a efficiency of 5 units per day. If the job got completed in 60 days, 20 days are already taken up. How many more days are remaining? 40 days. So A and C will work together for 40 days. So what is the total job that they've done? 7 into 20, 140 units here, and 5 into 40, 200 units here. So 140 plus 200, can I say total job is of 340 units? Now what is it that they're saying? Number of days needed by C to complete the job alone. What is the rate of C? The rate of C is 1 unit per day. So to complete 340 units, how much time will this person take? Will take 340. Perfect. Excellent question. Uh, Fantastic. Correct answer. Mehul, I believe just silly mistake in adding up the sum total to get the total work. Otherwise, I'm pretty sure you also got this right. Correct answer for this question will be 340 days. Definitely a question of type A. Look at it, attempt it, get it right, move on. And look at the neatness in which we are able to solve this once we have created this representation of MRTW. Super useful across all category of questions. Correct? Alright, let's move ahead to the next question. Now this is where time and work becomes interesting. So look at this question, try and understand what is it that is the key message here. How do we approach, and as somebody asked, how to tackle this particular category of questions in time and work where there is something very different or non-standard that comes out. For example, this is a very different question type. For whatever amount of practice anybody would have done from different sources, such questions are very rare. I'm not saying they don't appear, but they are very rare. All right. Just on the basis of this part, I've read the question. I'm sure you people would have read the question too. Just on the basis of this part, if the task needs to be completed in 10 days or less, then the minimum possible amount in rupees required. Just on the basis of this, I'll categorize this as type B and maybe come back later once I've finished off all the very easy questions of type A, something that was there in CAT 25 slot 2. But if such a question comes in my slot, I'll maybe mark it for B and come back later. Only because this is new. This is this kind of information where I have to finish the task. There is a range, 10 days or less. So they're not saying complete it in 9 days exact. Any time less than 10 would be fine. Minimum possible amount. Then there are amounts given. So maybe doable. I'm not saying just because it's unfamiliar, it's not something that I'll not be able to do. But I'll come back to it later. This is not a question of type A for me. So let's move ahead. A, V and T working alone can complete a piece of task in so many days. They charge rupees Z's per day respectively, even if they are employed for a partial day. Which means per day you will have to pay 2160 rupees to Arun, even if you are using him for half a day or 3/4 of a day. So partial payment for a day is not possible. You'll have to pay them fully. Per day charge is given. What is it that they charge? On any given day, any of the workers may or may not be employed to work. So we may ask certain people to work together. We may ask some people not to work. So we might have just A and B working together. We might have all three working together. We might just have a single person working. Some people may or may not work together. That is the idea. Now we want to finish off the task in 10 days or less, and we want to minimize the total payment required. So think of it from a perspective of somebody who is going to hire them as vendors to complete a piece of task, and you want to minimize payment. You want to get the job done in as less an amount as possible. How will you approach this? What will make you sure that you are paying the least possible amount? You will try and calculate who charges the least despite being able to complete a job in certain days. So how do we calculate that parameter? So what I'm going to do now is I'm going to write the amount of days these people take. For example, A, V and T, they take 24 days, 21 days and 15 days. Suppose I want to get the job done by only one individual at a time. I just want to see how much will I pay them. So suppose I ask this person Arun that take up this job, take 24 good days, whatever you take, and I'll pay you for your payment as per the conditions, which is 2160 rupees per day. So what is the total payment I'll be making? I'll be making a payment of 24 into 2160. I can compare the payments similarly for Varun and Tarun as well, where I'll calculate that if individually they were given the whole task, what is the total payment that I'm required to pay them. And then therefore, whoever gets paid the least, I'll be able to identify that this person will be the one that I'll want to pick to get the job done, because effectively this person gets charged or gets paid the least. Now, a very smart thing for us to do will be to deal with ratios and not really calculate 24 into 2160. So I'll write the corresponding per day payment for Varun, which is 2400, and for Tarun, which is 2160. Now, it doesn't really matter if I just want to compare who is charging me the highest, who is charging me the lowest, by just taking simply the ratios rather than actual values. So all these values are getting cancelled by 3. So I'll cancel this by 3, 3 8 za, 3 7 za, 3 5 za. And these values per day charges, I'll also take the ratio. So I can cancel zeros, and now they can further be cancelled. 24 10 is 240, 24 9 is 216. You can further cancel it with 4 first and then 6 first. That's also fine if you are not very good with ability to identify the common factor. So 24 9 za, this is 10 za, this is 9 za. So 9 is to 10 is to 9 is basically the ratio in which they charge per day, and 8 is to 7 is to 5 is the number of days that they take in ratio to complete the piece of work. So 8 9s are, this is 72, 7 10s are, this is 70, 9 5s are, this is 45. Now what is this data telling me? That if I individually ask Tarun to complete the piece of work, I will be required to pay him 45 days. He will work for 5 days and he'll charge me 9 rupees per day in ratios. Varun will work for 7 days to complete the piece of work and he'll charge me 10 rupees per day. So I'll have to pay him 70 rupees. Whereas Arun will work for 9 days and he'll charge me, he'll work for 8 days and he'll charge me 9 rupees per day. So I'll have to pay him 72. So this person Arun is the costliest for me, and this person Tarun is the person who will probably take the least amount of money from me if I ask him to complete the piece of work alone. Now, I want to get this piece of work done in the least possible amount. So now we can create this structure that we are so used to, MRTW, use the absolute values for the corresponding times of AVT to get the total work and the corresponding rates. So the times are 24, 21 and 15. The common factor is 3, and then you have 8, 7, 5 as the simplest ratio. 56 into 5 is 280, 280 into 3, because 3 was the common factor that I took out. So I'm assuming the work to be 840. Now 840 divided by 24, this is the LCM of 24, 21 and 15. 840 divided by 24 will be 24, these are 72, 12, 120, 5 are 135, or you could directly multiply 7 and 5. Similarly for 21 you will get 40, and for 15 you will get 56 as the rate for Tarun. Understand what do we mean by this? The rate for Tarun is 56 units per day, and if he works alone for 15 days, he'll complete our assumed piece of work of 840 units. So our work is now identified in a numerical value 840. We want to get this done within 10 days or so. So I'll first ask Tarun to work for 10 days. So Tarun works with a rate of 56. If he works for 10 days, he will complete a work of 560 units. Tarun will complete a work of 560. We need 840 to be completed. So if we subtract 560 from 840, we are left with 280. Next, we will ask Varun, because Varun then charges the lease. His rate in ratio terms is 70. So we'll next ask Varun. Varun's rate is 40. If we ask him to just work for 7 days, remember 840 minus 560, we are left with 280 units of work to be done. 40 into 7 itself is 280. So if we go by this, we'll be able to finish off the entire work of 840. If this is the case, 10 days payment of Tarun would be required and 7 days payment of Varun would be required. That is the total minimum amount required. So Tarun will take 10 into what is the amount that he charges per day? 2160. What is the amount for Varun? 7 into 2400. Let's quickly add these values up. So for Tarun, the corresponding value is 21,600. For Varun, the corresponding value is 16,800. 24 7s are 168. Let's add them up. So we have 0, 0, 8 and 6, 14, carry over 1. This is 8 and this is 3. So 38400. Correct answer is option 4. Now believe me, this is a difficult question. Having seen this in detail, once you revisit it, solve it again, you might feel that no sir, this is easy, this is moderate, this is doable. But in the exam pressure, after you've spent 80 minutes in VRC and DLR section combined together, at the last 40 minutes, you might not see this as the first 4, 5, 6 question. You never know in which order questions might come. In the exam scenario, I would rate this as a difficult question. So when I said type B, if after coming back, marking it for review, still you feel you're not able to figure out, you will skip this question and move on to something else. This is the very question that I wanted to discuss, questions from time and work in this particular live session, because such questions tend to make you feel grounded. There are some more questions like this which are different from the usual working efficiency and calculating time and combining rates and getting answers, that you should not take anything for granted. Don't take time and work to be a topic that this is very easy, this is my area of strength, I'll definitely be able to do. This is a slightly challenging topic. If you look at last few years papers, certain questions have been time consuming. They have used up concepts from different areas. Having said this, still relatively easier than some of the other question types across other topics. So in no way I'm saying that time work is difficult. I'm saying different question types have appeared in the last few years and we need to take care of that. All right, let's move ahead to the next question. Try this one. This is from CAT 24 slot 3. We have completed all questions from CAT 25. All right, just by giving you this much seconds, I think you should get a good hang of things in the first 10, 15, 20 seconds that you're reading. Sam can complete in 20 days. Mohit is twice as fast as Sam, twice as fast as A. They undertake an arrangement where Sam and Mohit work together first day, then S and A second day, M and A third day. Is nothing different than what typically we study in time and work. Very straightforward, very standard. I'll categorize this question as type A. Let's jump to solving it. So I'll start with the structure for the three people. Mohit, you have Sam, and you have Aina. And Mohit is twice as fast as Sam. So if Sam is 1, Mohit is twice as fast as Sam. And thrice as fast. Mohit is thrice as fast as A. So for A, the rate will be 2 by 3. It's always a good idea to deal with integers. So I'll multiply all the values by 3. So it will become 2 3s are 6. This will become 3 and this will be 2. Just remember 6 3 2. I'll erase this and I'll the corresponding rates for MSA to be 6, 3 and 2. You can cross verify. Mohit twice as fast as Sam and Mohit is still thrice as fast as A. Now they undertake a job with an arrangement where Sam and Mohit together work on the first day. So Sam and Mohit for day 1, you will have the combination of M plus S and they will finish off how many units of work? 9 units of work. Then what they're saying, Sam and Aina on the second day. So day 2, you have S plus A. You'll have 5 units of work getting completed. And day 3, you will have the remaining people, which is M and A. So you'll have 8 units of work getting completed. And this pattern goes on. So you can replicate this pattern of 3 days over and over again. How do we know what is the total work? The first sentence, S can complete a job in 20 days. So we can put this 20 in our standard structure. 20 into 3, 60 units of work is something that the total work is. And this is the pattern that we need to follow. So in 3 days, if you add up, can I say 9 and 5, 14 and 8, 22 units of work is done. In 3 days, 22 units of work is done. So in 6 days, you will have 44 units of work done. Now we are left with what? 16 units of work still being required to do. So for the 7th day, you will have 9 units of work done. For the 8th day, you will have 5 more units of work done. So in 8 days, you will again have 14 and 48. You will have 58 units of work done. And a part of 9th day would be required to complete the work of 60 units. I will take care of exact timelines, but let us see what is being asked. What fraction of the total work done by Sam? Then the fraction of total work done by Sam is. So total work is 60. We need to calculate what contribution has Sam made. So Sam has worked on day 1. Sam has worked on day 2 as well. So in the first 3 days, he has worked on 2 days. In the first 6 days, he would have worked on 4 days. Day 1, day 2. Then day 3 did not work. Day 4, day 5, he would have worked. So in 6 days, he has worked on 4 days. What about 7th day? Did he work on 7th day? Yes. Did he work on 8th day? Yes. Did he work on 9th day? No. So across these 9 days, he has worked on 6 days. And what is the efficiency for Sam? 3 units. So he has worked for 6 days with an efficiency of 3. That's it. That is the Sam's contribution. We can cancel 6 and 60 10 times. You'll get the answer as 3 by 10, option 2. Again, I'll say that this is a relatively easier question and we can identify these questions just by the language. Correct answer question, fantastic. 3 by 10 is the answer. Let's move ahead to the next question type. From CAT 24 slot 2. Again, take few days, try and see whether you would want to pick this as type A, type B, type C, and then we'll move ahead towards our approach for solving it. All right. Now, if you just look at the story and overall the length of the question, you will straight away want to not mark it as type A. A and V together can complete a piece of work in 150 days. V and S together can complete the same task in 100 days. A starts working, works for 75 days. Then Vimal takes over, works for 135 days. Finally, S takes over, completes it in 45 days and stuff like that. So there is a huge story to understand what could be the total work, what could be the corresponding ratios with which they are working. And then finally, so sorry. Finally, there is also the story of if A had started the task alone and worked on all days, Vimal worked on every second day, Sunil worked on every third day. Now, before we actually move on and solve the question, just one important pointer in terms of your ability to learn from every question. Forget about solving the question. Just tell me what pattern do you foresee? We'll calculate the pattern later on. But what pattern do you foresee if there is one person who is working on all days? So day 1, 2, 3 is working every day. There is another person V who is working every second day. So you will have somebody working on day 2, day 4, day 6, day 8, every second day. And Sunil had worked on every third day. So there's a person working on day 3, day 6, day 9, and so on. Is there a particular pattern? Can you tell me if at all we'll get a pattern? Just like we got a pattern in the previous question, 3 days, 22 units of work. So we can replicate those 3 days later on. Is there a pattern that you can foresee? If not, this could be a good learning for you for any questions of this type, useful for progressions as well later on in general. So if somebody is working every day, somebody is working every second day, somebody is working every third day, then they will all work together on the 6th day. And then again the same cycle will start. So we'll definitely get a pattern in 6 days. It's for sure. Alright, so let's move ahead now with regards to the data that is available. So we can structure this on the basis of whatever information we have in our MRTW structure. A and V can together complete a task in 150 days, while V and S together complete the same task in 100 days. Correct? Now, can we take the LCM and say, let's assume the work to be 300. So the rate of A and V combined will be 2, V and S combined will be 3, right? Now what happens? A starts working on the task and works for 75 days. We don't know the rate for A. Let's assume the rate for A to be small a and works for 75 days. Then V takes over. Let's assume the rate for V to be B, small b, and he works for 135 days. And then finally S takes over, works with a rate of, let's say, C, and finishes off the work in 45 days. So we have already assumed our work to be 300. This 300 is actually equal to 75 into A plus 135 into B plus 45 into C, where we know that A plus, if I write it in the form of equation, I know that A plus B is 2 from this data. From this data of 3, I know that the rate of B and C combined together is 3. And I know that this 300 is equal to this value. Now you have 3 equations and 3 variables. There will be a lot of people who will want to solve these equations via standard method and get the answer. We can do that as well. But when you have such simple equations where A and B are 2, B and C are 3, and you just have to verify whether this total for ABC will be equal to 300, can you just think of putting values by hit and trial and getting the answer? What could be the integer values to get the sum of values as 2, 1 and 1? And so if I assume that A is 1, B is 1, if B is 1, C would be 2. Just try and fit in these values of A being 1, B being 1, and C being 2 here to check if the total work comes out to be 300. If it does, this is right. If not, we know that we can maybe mark it for review and come back later to solve 3 equations, 3 variables if time is not permitting us to pick up this question. Alright, so let's put these values. 75 plus 135, that will be 210, and 45 to the 90, this actually is equal to 300. So pretty straightforward for us to calculate A, B and C, the rates of these people. So now we have the rates, we also have the work. So we need to complete 300 units of work, but there is a pattern. What is the pattern? On day 1, 2, 3, 4, 5, 6, A will work. A will work on all days. So just to elaborate it, I can create a structure later. But in the exam scenario, the way you can approach it would be like this, that let's calculate for how many days in a pattern of 6 days. Now, how do we get 6 days? We take the LCM of every second day, every third day, and all days, which is 1 unit, which is frequency of 1 unit, frequency of 2 units, frequency of 3 units. So in 6 days, can I say A works for all 6 days? What about B? B will work on second day, fourth day, sixth day, every second day. So B will work for 3 days. And what about this person C? So instead of C, let's actually write the names of these people as AVS so that there is no confusion. Sunil will be working on third day and sixth day. So Sunil will be working for 2 days. So these are the days in which they will work. The rates of these people are 1 unit, and for Sunil it is 2 unit. So in 6 days, you will have 6 and 3, 9 and 4, 13 units of work being done. So in 6 days, 13 units of work is done. We need to go close to 300. So what is the value which is a multiple of 13 closer to 300? Let's divide 300 by 13. So 13 2s are 26, will be left with 440, 13 3s are 39. So 2s and 3s are 23 into 13 will be 299, left with a remainder of 1. So 23 into 6 cycle of 6 will have 138 days. So in 138 days, we'll be able to finish off 299 units of work. 1 unit of work is left. And they're asking the number of days that will be required to complete this piece of work. So now on the very next day, A will be working with a unit of 1 unit per day. So one more day after this, so 138 plus 1, 139 days would be the answer. Now, this you would be able to do if you are really good with your ability to understand when will the repetition of works happen, how will the pattern repeat itself. Having understood this, I am now going to erase this much part and explain to you that how did we arrive at this 6 days pattern. So let me erase this. I'm pretty sure that this is clear to all. We have got the answer, we have solved this question, but just to elaborate it and understand what is happening across each days, just visualize it this way, that we have D1, D2, D3, D4 and so on. We don't know yet what is the pattern that we are going to get, if at all we are going to get any pattern. And we have three people, A, V and S. What you can do is, this person A will work every day. This person is going to work every day. What about this person B? He is going to work on every second day, D4, D6 and so on. What about this person S? He is going to work on every third day, so D3, D6 and so on. So what is going to happen? How do you recognize the pattern? Look at the first 6 days. On the 6th day, we can find all three people working, and therefore the next day will be a reset cycle. This person will not work, this person will not work, this person works every day. So on day 7 only, 7th person will work. How did we arrive at this? What was the frequency for A? Frequency for A was 1 unit every day. What is the frequency for V? 2 units. What is the frequency for S? 3 units. What is the LCM of 1, 2 and 3? 6. So we'll get a repetitive pattern in 6 days, every 6 days. Therefore, we could calculate what is the amount of work done in 6 days and then take it from there. I hope this is clear to all. Alright, let's look at the next question. Alright, so just on the basis of quick reading of this, Renu would take 15 days working 4 hours per day to complete a certain task, whereas Seema would take 8 days working 5 hours per day. This seems to be a standard straightforward question. We should mark this as either type A, try and attempt it, or maybe as type B, definitely not type C. Let's quickly write down the structure. So we have Renu, we have Seema, and Renu would take 15 days working 4 hours per day to complete a piece of work, whereas Seema would take 8 days working 5 hours per day to complete the piece of task, to complete the same piece of task. Therefore, if I assume the rate of Renu to be A, for Seema to be B, we multiply, we get 60A is equal to 40B. We can assume the work to be 120, multiple of 60 and 40. So we can get the corresponding values for the rate of A to be 2 and the corresponding value for B to be 3. So Renu has an efficiency of 2, Seema has an efficiency of 3. Now, what they are doing, they decide to work together to complete this task, which means this task of 120 is being taken up by these two people. So we have R and S working together to complete this piece of task. A is 2, B is 3. So these are their individual rates. And now they are saying Seema agrees to work for double the number of hours per day as Renu. Okay. Double the number of hours per day as Renu. In the last sentence, they are saying if Renu works 2 hours per day. So Renu works 2 hours per day. And Seema agrees to work for double the number of hours per day as Renu, which means Seema will work for 4 hours per day. Further, they are saying, well, Renu agrees to work for double the number of days as Seema. So if Seema works for X days, Renu works for 2X days. Now that's it. Number of days Seema will take. So we are expected to calculate the value of x. If we calculate the work done by Renu, we can multiply this. So 2 into 2, 4 into 2, 8x. 8x is the work done by Renu. And if we multiply for Seema, 3 4s are 12 into x. 12x is the work done by Seema. Why have I added them? Because they are working together and this work is equal to 120 units. That's it. That's our answer. We have 120 being equal to 20x. You can cancel this 20 with 126 times. Get our answer for x as 6. Very neat and clean, straightforward approach for a standard question type from CAT 24 slot 3. I hope this is absolutely clear, and which is why I'm a big fan of this approach where you can structure it very conveniently. Right? Let's move ahead to the next question. All right, this is probably the most difficult and or time consuming question ever asked in the last 9 years history of CAT since CAT 2017. So if you look at any question paper, any slot since CAT 2017, you would find this question to be the most difficult or time consuming question. There is one more similar question which I'll share, which is equally good enough to be qualified as the most difficult from this very topic of time and work. Will we be able to identify it in exam as difficult or type C? Let's try and assess. So there are 3 people, let's call them R1, R2, G, would take more than 7 days. Now this is your first red flag. They're not giving us direct data, exact 7 days. They take more than 7 days. On the other hand, Rahul and Gurmeet working together would have taken less than 15 days. Again, a range. However, they all worked together for 6 days, followed by Rakshita, who worked alone for 3 more days to finish the job. So with this, we can have the total work available. That if they work for 6 days and Rakshita alone works for 3 more days, this is the total work. If Rakshita had worked alone on the job, then the number of days she would have taken to finish the job cannot be, which means 3 options can be, which means there has to be a range for Rakshita to finish the job. Just on the basis of these clues, we can say that you're not going to attempt this straight away. Unless you've practiced such questions, you're super confident of your abilities, and you're really good at time and work and other algebra related equations and inequalities, you should skip this question in the exam scenario. Now let's try and see what is it that we could do to solve this question. Let's structure this in a simple manner the way we have been doing. Rahul is, let's say, R1, Rakshita is, let's say, R2, and Gurmeet is, let's say, G. They take more than 7 days, so time is more than 7. On the other hand, Rahul and Gurmeet would be R1 plus G. They take less than 15 days. Okay. Let's assume their rates to be ABC. So A plus B plus C working for more than 7 days will finish the job. A plus C will take less than 15 days to finish the job. Fine. However, they all work together for 6 days. So we'll have R1 plus R2 plus Gurmeet, which is A plus B plus C, working together for 6 days. So they will complete 6A plus 6B plus 60 units of work. And now what is happening? Now Rakshita, which is R2, she is working for 3 more days alone to finish the job. So the rate for her is B, and she is working for 3 more days. So 3B extra units of work is getting done. If we add them up, we get the total work. So I'm writing total work as 6A, 6B plus 3B, extra 3 units alone done by Rakshita. So that would be 9B plus 6C. This is the work that is there. Now they are asking if Rakshita had worked alone on the job. So Rakshita will work with a rate of B. So let's write it down. The time taken by Rakshita would be the total work 6A plus 9B plus 6C divided by the individual rate for Rakshita is B. So we can simplify this and say 6A plus 6C, we can take 6 common. We'll have A plus C by B plus 9B divided by B, 9. So we know for sure that the answer is greater than 9 plus 6 times this factor of A plus C by B, which is why we have multiple options that this work cannot be. So depending on the range of a plus c by b. Now how do we get the range of a plus c by b using the first two inequalities, greater than 7, less than equal to 15. So there is still a lot of work to be done. But if you had to make a calculated guess, understand that the answer will be 9 plus some range. So either the answer will have a lower limit or an upper limit. So the smallest number is 16, the largest number is 21. Generally the answer would be either 16 or 21, something along these lines. But this is a jugaad approach. We still don't know the exact answer for sure. How do we calculate the exact answer? We will put this work, divide by the corresponding rate of ABC, and put this time as greater than 7. So let's do it here. So I'm going to solve this part of the equation greater than 7. So we have the total work as 6a plus 9b plus 6c divided by a plus b plus c. This has to be greater than 7. Correct? Let's cross multiply and simplify. So we'll have 7a, 7b, 7c. When you have 7a, 7b, 7c, you will have 9b minus 7b, which is 2b, greater than, you will have 7a minus 6a. It will be a plus c. So a plus c is less than 2b, or in fact we wanted a factor of a plus c by b. So we can say a plus c by b is definitely less than 2. So the max value that it can have is 2, not even 2, less than 2. So 6 into 2 plus 9, 12 plus 9, 21 is not possible. 21 is an option, so correct answer is choice 2. You don't need to make use of this because we were lucky, because this equation yielded us the upper limit. Had this equation yielded the lower limit, we would have to use a second inequality. So 21 cannot be the answer because this number a plus c by b has to be less than 2. But this is a super time consuming difficult question from a very easy topic of time and work. So I hope this is clear as to how to approach this question. We can further create an inequation for this 6a plus 9b plus 6c divided by a plus b plus c. It is less than 15. Oh, sorry, just a plus c, in fact, a plus c. So we can cross multiply and say 6a plus 9b plus 6c is less than 15a plus 15c. So effectively we'll have 9b, what is left? 6a plus 9b plus 6c divided by a plus b less than 15. So we'll have 9b less than 9a plus 9c, or we'll have 9 getting cancelled, b or rather 1 being less than a plus c by b. So the lower limit is 1. So we'll have the range as 15 to 21. But this range is not required. We were already able to solve the question. But this is a super time consuming question as far as time and work as a topic is concerned. Now, this question, again, last few questions that I'll take up so that we at least finish off the questions from the last year's paper. Not giving you time. Gautam and Swani working together can finish a job in 20 days. Straightforward. If Gautam does only 60% of his usual work, and Swani then must do 150% of his usual work to exactly make up for it. If you can understand this line from the perspective of allegation, in one of the live sessions we dealt with allegations. You can understand allegations here. You are a champ. So we have this basic structure. We know that Gautam and Swani working together can finish a job in 20 days. Now they are saying if Gautam works at only 60% of his efficiency, Swani must work at 150% of efficiency first to make up for it, to make sure that 100% efficiency is still there. So I can use allegation and say 50 and 40, the ratio of their efficiency is 5:4. So Gautam 5, Suhani 4, 9 into 20, 180 units of work is there. Now the question is asking number of days required by the faster. Faster is Gautam, 5 is the efficiency, 180 is the work, 180 divided by 5, 36 days will be the time taken by him working alone. Question done. A super fantastic approach using allegations. Now moving ahead, this was a relatively easier question. There's one more question on similar lines as the one that we did previously. that particular question could be done in a very different alternate way using options. So try and look at that question from CAT 23. We have already solved one such similar question. We'll try and see if we can use that approach to solve questions of similar nature. So broadly, it is close to 1 hour that we have been discussing questions together. That's it from my side. Do let us know the kind of sessions that you would want in future. How did you like these sessions? Any particular question or approach that you liked? Whether you're able to apply this while you're solving questions on your own? Anything and everything that you would wish to share and expect from us in the coming few days and months going ahead. This is where I'll end the session. Thank you so much for being patient and attending the session throughout. Thanks, Krishnan. Actually, you can watch the recording again for this session, Anamika. If you're not able to follow that particular principle of the pattern for 6 days, thank you everyone. Thank you, Shreya, for attending the session. We'll have some more sessions on similar lines planned for you. Do share.